Okay, we are going to discuss about 4.1c, continuing on with part two. And specifically, I just wanted to make this a part two because there's just so much in 4.1c. But this very last part, I wanted to make sure I had enough time to dive into the details of it. And what we're discussing is that arc length, and so we're gonna cover arc length and circumference and radius. So, but arc length and radius mostly. So let me give you an example. So let's say I have this circle, and it has a an angle in it, a central angle, and we'll call that angle theta always. And let's say theta here is 30 degrees. And the radius is, we'll just say this is 4 inches. The radius being 4 inches. And we want to know, what is this arc length? What is this particular length of this circle right here? What is this? We position our degree in terms of a proportion, right? Because this is 30 degrees. So proportionally, wouldn't the arc length be 30 degrees? Think of an entire circle. The entire circle is 360 degrees. So the entire thing is 360 degrees. So that arc length in itself is a proportion of that 360 degrees. So first we have to write in that portion, and that proportion is 30 degrees out of 360. So that is the proportion of that circle. So now how do we actually find the length? Well, the proportion of the circle, isn't that also the proportion of the circumference? So we take that proportion and we multiply it by the formula for circumference. And the formula of circumference is 2 pi r, is how I like to remember it. Or the diameter times pi, right? But all these, same thing, 2 pi r, diameter times pi. Here we're given the radius. So it's going to be times 2 times pi, and now the radius is 4. So if I multiply all that out in my calculator, and they just want this in, they don't want pi in their answer. So let's say 30 times 2 times pi times 4. Divide that entire thing by 360. Proportionally, this is 2.09 inches. So we can do some other examples with this. So what if we are given now, right? We are given the radius. We're given the radius. The radius is not the best circle, but the radius is 15. So radius is 15, we'll say feet. 15 feet. And our arc length, now we're given our arc length. And they say our arc length here is 6 feet. So this is 6 feet. So our arc length is 6. And they want us to find the degree. And this time they want us to find the degree in radian. And finding the degree is just fine. You can find it in radian. You can find it. So instead of using 360, this time we have to think of it in terms of radians. Radians is pi over 180, or the entire distance around the circle, 360 degrees, is 2 pi. So let's put that to work. So we know that to find the arc length, right? We know that the arc length, so it's 6, must equal 2 pi r. So 2 times pi times r is 15. And now we have to put in the proportion, right? Because that arc length is the circumference times that proportion of how many radians it is. So this is, we want to know how many proportion. So this would be our radians, yeah. Or I'll call this the radians. All right. Let's not call that radians. We'll just say theta. We'll call this theta. Theta over 2 pi, because the entire thing is 2 pi. Okay, so now I can first, I'm going to simplify before I even multiply anything else. I notice that 2 pi and 2 pi, you can cross simplify that and you get just 1. So these two kind of cancel each other out to make 1. So then you're left with 6 equals 15 theta. Divide both sides by 15. Theta is then, you can reduce 6 15ths by 3. So that is 2 fifths. So our answer is actually 2 fifths radian is our degree right there. Let's go to, instead of now the arc length, let's work with area. So let's say we are given the area of the sector. They want us to find the area of sector. We are given the radius is 2.5 feet. The central angle is 135 degrees. So if I were to draw a picture really quickly, it kind of look like this. It's a wider circle. This is 2.5. This is 135 degrees, and they want us to find all the area inside this, I like to call it the slice of pie right there. So this slice of pie. Well, and now instead of working with our circumference formula, we're going to work with our area formula. So quick reminder, the area of a circle is pi r squared. We want this circle to, this pi is also, just like that circumference, it is also proportion of the entire thing. So all you have to do is first find the proportion. So we got 135 out of 360. Multiply that by pi. Multiply that by 2.5 squared. Yeah, radius squared. I'm going to punch that out in the calculator. Times pi times 135. Divide everything by 360. And I get 7.36 feet squared. Remember, it's feet squared for that area of the pie. Last example here, we're gonna discuss what if we were given cities and we needed to find the distance in between the two cities. So first things first, the earth is a sphere, which is big circle all the way around, and we want to find the true distance of the cities, not just straight flat up and down as you would see in a map, but distance including curvature of the earth. So let's say we are given a city, we'll call this city A is, what to say, at latitude 57 degrees, 38 minutes and 20 seconds, and city B is, we'll say, 12 degrees, 15 minutes and 17 seconds. So what I can do is first, I'm going to just convert this into using my calculator. Punch in 57 degrees, 38 minutes, and 20 seconds, and get a decimal amount. So for city A, I got 57.88 repeating. City B, 12 degrees, 15 minutes, 17 seconds, and this gives me 12.2547, and 2 repeating in terms of city B. So now I want to know the degree, the difference, right? The actual angle. To find the actual angle, I just need to find the difference between 57 degrees, 57.688 repeating degrees, and 12 point something degrees. So I'm going to punch that in, 57.638 repeating minus my answer, that minus 12 something. And so the difference, they're subtracting the two, I get 45.38416 repeating. So that is my actual degree that I'm working with. Oh, well, now I have the actual degree. Now I can use my circumference to actually find the distance, because the circumference of the Earth being a sphere, we can put that down as a circle. So 45.38416 divided by 360, and assume the radius of the Earth is 4,000 miles. So we're going to assume that. So it's 2 pi r, so times 2 times pi, and I get 4,000 miles from assuming this is the radius of the Earth. It's 4,000 miles here. So let's see here, divide by 360 times 2 times pi and times 4,000. So these two cities are actually 3,168-ish miles apart right there. And that is all we have to do.